Welcome to the Math Help channel. This is the part 2 to my U-substitution. If you saw the first part, we did U-substitution with a couple trig functions. The reason I'm doing this second part is because I said the last problem I was going to do in the first video was going to be a radical, and for some reason I decided to switch and do another trig mixed in with a logarithm. So this will just be this video will just have one problem, and it'll be a radical, so we can see how to do it. Alright, so what we have here, now again, this is assuming you watched the first video or you understand at least the basics of integration. This is a continuation of U-substitution. So the problem here is the integral of 2x cubed times the cube root of 2x to the fourth plus 1 dx. So what we're going to do is, remember, we want to choose, so what I'm going to do is I'm going to rewrite this expression because we want it to look like u du. That's what U-substitution is. So what we're going to do is let's rewrite it so it's easy to pick out what's going to be u and what's going to be du. Usually you want the easier of the two functions to be multiplied with dx. So that in this instance it's going to be 2x cubed. Now remember this. So let's see. Let's make it. So it'll be cube root of 2x to the fourth plus 1 times 2x cubed dx. Now, let's remember the end of my first part. I made a connection between radicals and exponents. Remember being able to convert between radicals and exponents. So make sure if you don't remember that, go to my last video on this topic. So I'm going to rewrite this as 2x to the fourth plus 1 raised to the 1/3 times 2x cubed. All right. So notice we have a function within another one. So that means we're going to make this du, not du, u. Now remember, when we take its derivative, it should be somewhat of a constant multiple of this. For example, if I made this just 2x, when we take, let's see, hold on, 2x to the fourth plus 1. If we take its derivative, we get 8x cubed dx. Now notice how this is a similar, a constant multiple of this. So if I made that, if that was just dx, 2x dx, these aren't close at all. We cannot multiply this by, divide this by x squared. You just can't do that because then you're introducing multiple variables, or an extra operation with those variables, and you can't just plug in that independent variable in there. You can't do that. So back to that. So now you ask yourself, what can I multiply this by to get this? What can I multiply this by to get that? Well, I can multiply this, both sides, by 1/4. Now you can't really read that, can we? That means this marker is 1/4. We'll multiply everything by 1/4. So then that means we get 1/4 du equals 2x cubed dx. Now notice what we have here. This is the same as that. Hoorah! So now let's make that substitution. Now remember it. Alright, so then this is now u. This is now u because we were able to choose it for u, choose this function for u, and then take its derivative. So then now this integral, fourth plus 1, times 2x cubed dx is now going to be integral of u to the 1/3 times 1/4 du. Why 1/4 du is because we were able to multiply this by some constant to make this side equal to this, and then we can make that substitution. Now remember that 1/4 can come out, so we get 1/4 integral of u to the 1/3. Now, unless you want to switch back to integrating a radical, by all means, be my guest. But I recommend leaving it in I almost insist upon you writing them in terms of an exponent, because then you can use that power rule that I told you for integration. So what you do is you increase this power by 1 and divide it by its exponent, by its new exponent. So this would be times u to the 1/3 plus 1, which is 1/3 plus 3/3, should be 4/3, and that's a little too close. So let's give it some more room here. 1/4 times u to the 4/3, and divide that by the new exponent, 4/3. I can't quite read that. Again, I have a glare, sorry. Plus c. So let's fix that. So let's bring this out of the denominator, because I don't like a fraction in the denominator. So we get 1/4 times 3/4 times u to the 4/3 plus c. We can put these fractions together and put our u back. Actually, you know what? Here, I want to have these all on one line. So equals 1/4 times 3/4 times u to the 4/3 plus c. We want our u back, so we're going to plug in what we had in for u right here, and we're going to plug that right back into the function, because again, the original problem is in terms of x, not u. So let's plug it back in, and when you multiply everything out, this is 3/16 times 2x to the 4th plus 1 all raised to the 4/3 plus c. If you guys have any questions about this problem or anything in particular, send me a comment. Please subscribe, and if you have any problems or topics you want me to cover, please send me a message on this channel, and I will get to it as soon as possible. Thank you for watching. Have a great day.